Hello, Math 7 students. This is Mr. Kraft coming to you from my house as usual. I hope you had a great spring break. I know being stuck at the house all the time might not have been the most fun in the world, but at least you were off school for a bit. I hope it was enjoyable for everyone. I hope everyone had a blessed and wonderful and holy Easter weekend. And I hope everybody is all set to go back to school. You won't be physically going back in person yet, but at least we can get things started today. So we're on section 9.6, page 408 in the textbook, and I want to talk to you about surface area. And in order for surface area to make sense, I need to talk to you about solid. Now, earlier, back before the break, we talked about polygons. Polygons are flat figures, figures in a plane. Solids are, well, solid. So, for example, a square or a rectangle is just that, but a box is a solid object. A triangle is flat, but a pyramid has an actual shape. Well, if we're going to talk about solids, we need to know about the kinds of solids there are. Just like we talked about different kinds of polygons. You have triangles and squares and pentagons and hexagons and all kind of fun stuff. So let's talk about the basic types of solids. So the maybe simplest kind of solid is like the three-dimensional equivalent of a square. A square has all four sides equal. Well, all the edges of a cube are equal to. And I'm drawing a bigger cube so we can get some of the terminology down. With a square, we say it has four sides. We don't, people do use the word side for a cube, for a polyhedron, the technical term for it, a solid. That's not really correct. You think of the flat sides of a cube, it's like a box. This front, it's not really a side, it's a face. There's a face. So you've got 1, 2, 3, 4. And if you count the bottom and the top, 5, 6. So it has 6 faces. And these little edges, well, that's what they are. They're edges. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 edges. I'm not too worried about the terminology at this point. I just want you to see what it is. So this is a cube. All the edges of a cube are equal, and all 6 faces are equal. Each face is a square. Each face is the same size. Okay. What if you have something like this, where it's not a cube, it's not all the same size? Well, the equivalent of this as a plane figure is a rectangle. So we call this a rectangular. Sometimes we call it a rectangular box, but the more official name is prism. Prism. A prism is a solid figure that has polygons for its side. The prism you guys probably are most familiar with. Might have seen one in Mrs. Sly's class when she was talking to you about light. If this is a rectangular prism, what is that? Well, the answer The triangular prism. So that's that. And you could have all kinds of prisms. In your textbook, it shows if you had 6 sides, a little bit harder to draw. That is a hexagonal prism. And you could have any kind. You could have hexagonal, heptagonal, octagonal, what have you. But we won't go there. If you have a shape like a soup can, or a can of pop or Coke or soda or whatever you call it, that is a circular cylinder. That is a circular cylinder. And if you have something like this, like an upside down ice cream cone, well, you know what? That's what we call it, a cone. Technically, a circular cone, because the base is a circle, just like both the base and the top of a cylinder are circles. A round ball-shaped figure is a sphere. So they say the Earth is round. That's not true. It's spherical. Round would be a circle, and a circle, ladies and gentlemen, is flat. So the Earth could be round and still be flat, the way that a CD is round and flat, or the way that a thin layer of a cake is round and flat. It is proper to say that the Earth is spherical, not just round. A circle's round, a circle's flat. The Earth is not flat, the Earth is spherical. I know that even I sometimes will say the Earth is round, the Earth is spherical. Dimensional figure. Okay. The surface area of a solid. What do you mean by that? What do I mean by that? Well, I'll tell you. Now, we talked before that if you have a flat figure, that's a horrible looking polygon. If you have a flat figure, like say a square, that which is inside of it is the area. What does it cover? If you had a square shaped piece of paper, you set it on a table, how much does it cover? Volume is space inside, so this is area, volume. So if I had a rectangular prism or rectangular box, if I'm just throwing stuff into it, I'm pouring water into it, or pouring sand into it, or throwing toys into it, or whatever, how much will it hold? That's what volume is. What is surface area? Let's take that box again. Well, a rectangular box has 1, 2, 3, 4, 5, 6 faces. So the area of the first face would be its length times its width. Then you take the second face, which I'm doing a different color. There's an area, going to be its length times its width. Then you're going to have this face, and then you're going to have that face back there. And then you're going to have the bottom, and I think I'm running out of colors here. Then you're going to have the top. So you've got the area of face 1 plus the area of face 2 plus the area of face 3 plus the area of face 4 plus the area of face 5 plus the area of face 6, and that's going to equal SA, which is the way some books write it, surface area. Surface area. They're using just the letter S for surface area in your book, which is fine. S is surface area. Now, obviously, for some shapes, you can't just break it down like I did with this rectangular prism, this rectangular box. That is definitely not going to, oh boy, that is definitely not going to work. Reading it in there. It's not going to work for a sphere. It's not going to work for a cylinder. It's not going to work for some of these shapes. So some of these shapes, these solids, do have specific formulas for surface area. I'm not going to go into that on today's video, though. I'm just giving you the basic concepts. One more thing before I close out. Cal does have an account on Zoom, and some or all of you may be aware that Zoom is a teleconferencing or video conferencing app. So it's like all of us could meet together via using our computers and the cameras and meet each other online without physically being present. The Zoom that Cal has also has a whiteboard on it, just exactly like what I'm using for this video. Now, I hope these videos are useful for you, that you can watch them and they make sense. But the disadvantage of them is that sometimes you might have a question. And unlike if I'm putting up stuff on the board in the classroom, you can there, you can say, Mr. Craft, what do you mean by that? Here, you can't do that. You can email me or you can question me through the Google Classroom, still not the same. But if we scheduled a Zoom with the whiteboard, then we could all meet together just like we would at Cal, except each of us would be in our own home. And I would have the whiteboard. So if somebody asked me, hey, Mr. Craft, what does that mean? I could just start doing something and say surface area equals whatever right here as you asked me that live in real time, just like we would in the classroom. So be sure, it'll take me a few days before we get there. I need to get the password for it. Talk to your parents, see about having access to a computer with a camera, because I would like to start maybe doing once a week or so a session with you guys that way. And I would just want everybody, as many as possible of you, to have access to that. I think being able to ask me questions and give you responses as you ask them would really be very, very helpful. So I'm going to leave it at that. I hope you have a great rest of the evening, and I will talk to you again soon. Goodbye.